Before moving on with the development of the application, I'd like to take a few minutes, in this video and the next one, that is, in the videos of this module, to rethink some of the things that we've implemented, to consider other alternatives, and even to consider aspects that we didn't see at the time, that we didn't notice before. Finally, at the end of the video, we're going to look at matters related to efficiency in the development stage in prototyping, how to reduce our work times. So let's start with something that we overlooked, and that is, for example, if we wanted the background color of our screens not to be white, but instead, for example, light blue. How would we go about it? We could create a class with the property background color light blue and associate it with the main table of each panel. But every time, we'll have to remember to make this association, which is not so convenient. If we inspect the HTML of our homepage, the body tag has the application class associated with it. This happens in general with frameworks such as Angular or React. Every HTML body tag will have this class associated with it, and therefore, it'll apply to everything that's placed inside the layout. What's interesting is that this class will also apply to native application layouts, Android, iOS. It doesn't matter that there's no HTML there, and the implementation is completely different. The application class will have the same meaning. Therefore, for DSOs that'll apply to the panels world, using that class to configure what we want to be valid for all screens is a good idea, and a cost-effective one. If we were in the web panels world, as for example in the back office, the body tag of the HTML would not have the application class, but the form class. So we would have to use this class there instead of the application. Well, but since we're in the panels world, because we're implementing for Angular, let's try adding the application class to our DSO with the background color property set to light blue. And I execute again. Okay, and if we look now, here we see the property. An important clarification. We're using something of low level that's not part of GeneXus to model something of our design system. A basic feature of the construction of an HTML file is that after the head tag comes the body tag that appears only once per HTML. So we're taking advantage of the fact that for frameworks like Angular, an application class, or form if we're not using frameworks, is associated with that body tag, to give a general style to the screens of our application using one of those two classes. But if in the future the application class were no longer associated with the body tag, all this would stop working. The same would happen if for web panels the form class were no longer associated with the body tag. We'll have to keep an eye on this because maybe in a future GeneXus upgrade, some of this will be modified, or some special property will be provided for this, or who knows what else. We go back. We hadn't paid attention to the background color because we hadn't noticed it, since the background color is white, and that's the default. But to be able to change it later, we'll need to explicitly set the value in the property to change it easily in the future. So, first, let's add a gray 00 color token. That's it. And now let's change the value of the property for the token. We could take advantage of this class that'll be applied as the root of all the objects with an interface of the panel's world to define there the Hebo font family and not have to repeat it everywhere. You may wonder how, if we've never repeated the font family so far. If for each of the three classes we have, there is a Hebo, yes, but it's different. Remember that what made them different, which was their weight, we decided to express it together with the family. But we could have kept both separate. So, I remove here the name that distinguished it, leave the generic Hibo, which is the one I also place here. I'll remove from all of them what differentiated them by name, and now all three will be called Hibo, and what will make them different will be their weight. So in class H2, I say it's the 700 weight Hibo. In paragraph, I'll say it's the Hibo 2, but with 400 weight. And in button, we'll say it's the 800 weight, Hibo 2. So to identify it now, we'll specify these two dimensions, because the difference between the Hibo fonts will be determined by weight. With these two dimensions, we know which of the font files will have to be used. Then, since the font family is repeated in all the classes that we have so far, I could take the opportunity to specify that font family as the default and remove it from here, here, and here, and place it inside the application class. This way, as this class is the root of each object with an interface, this will be the default font family. That is to say, the one that will apply if nothing else is specified in the classes. If we try this now, we'll see the white background again according to this token. But otherwise, we won't notice the difference, obviously. But if we inspect it, we see there the two properties inside the application class. And we don't notice any difference from how we had implemented the font aspects before. So it's another way of accomplishing the same thing. On the other hand, if we come to Figma to explore the typographic styles that our designer created for the screens, and we analyze, for example, the copyright one, we see that it's not using the Hibo font, but this Rubik one. And for this other text, the main text of the banner, the graphic font is used. We can conclude that Hibo will not be the only font family. There will be two others. What we know is that the Hibo font will be the main font of the application, the primary one, and that only in a couple of exceptions, other font families will be used. For the classes that use these other families, those of the text that we've just seen in Figma, it'll be enough to specify the family. For one case, it'll be graphic, for the other, Rubik, and in this way, they'll stop using this Hibo default, which was the default since we placed it in the application class. What we can do to better conceptualize everything, given that we're going to have three different font families, and this one is the main or primary one, is to create a token for each one, to abstract them according to their function. Tokens are not only color tokens. We can define tokens of other types, for example, for fonts. From this editor, we can add a new token of this type, fonts. I'll call my default font primary, which is Hibo. This name here will correspond to these three entries. From now on in the classes, I can use the token instead of the specific value. That is to say, the default font family will be the one indicated in the primary token. Primary for fonts and not for colors. They're not confused because they're in different categories. Let's save. Of course, when we need to use the other font families, it'll be convenient to create tokens here for them. In this way, it'll be quite easy to change the font families of the application without having to go through the Styles tab to modify in each class the font that's being used. And this is the great advantage of tokenizing. If we want to test it to make sure that everything goes well, it seems that yes, everything is fine. Note here in the application class how the token of the font family looks like. Well, Now I would like to discuss something else that was overlooked, and it has to do with the caption that we assigned to this text block control, but in the home panel. We had started by statically assigning this caption to the text block instantiated in the home panel. And to the text block instance in attractions, we had also statically assigned this caption at the control property level. Since this is static information configured in the properties of the control itself, when the panel is loaded for the first time in the browser, this information is already available and can be rendered immediately on the browser screen. Then, also on the client start event will occur. And if it doesn't have to invoke any service on the server, it's entirely executed there. The client start event is where we load the constant of this variable, remember? Let's look how we assigned a value to it in the attractions panel. For the variable, we had no other option but to load it by code, because for variables, we don't have a property that allows us to enter content. In this case, as its content was also static, note from the beginning, these assignments will be executed immediately in the client. Therefore, when we load the page in the browser, we'll see that the text caption and the variable text are loaded at the same time, without any flicker or delay or anything like that. Before moving on, I recommend you to review, or watch for the first time if you haven't done it before, this video of the Angular course on the GeneXus training site. It also explains the events for native applications. The events that are triggered on the client and those that are triggered on the server and their order are explained there. Going back to our work, for the text block in the home panel, we had to assign the caption by code to be able to divide it in 3 lines. Do you remember? Here, I only changed the order of the assignments. First came the text block 1, and then those of the variable, but now I inverted them, and I placed this, that since it's commented for now, it doesn't matter. When we implemented this, we didn't take into account, once the assignment was added here, to remove the caption set at the level of the control in the property. So, we have 2 caption assignments. To clarify the effect that this can have, I uncommented, this invocation to a procedure after loading the variable information, but before loading the caption of the text block. This invocation will be made to a procedure that I created earlier, and because it's a procedure, it'll be executed in the server. So, this server procedure will have to be executed as a service from the client, and the only thing that this procedure does is to call the sleep function, which implements a pause, in this case, of the number of seconds that we send it by parameter, which will be 1. When this time is expired, the procedure ends and the execution continues in the client in the following statement, executing then the assignment of the caption. To understand what I want to show you, it'll be best to execute it. It was clearly seen, wasn't it? If the application behaved like that, with that unexpected change in the layout, the user would surely feel uncomfortable and our application's rating would go down. It's not the same if the caption takes a long time to appear than if it changes. The latter is what gives a very unfavorable impression. I placed this procedure so that the change would be obvious to us. I'm going to remove it and run it again. It was unnoticeable in this run, but we can't be sure that it will always be that way. Also, we can't be sure that in the future, we won't add code in the client start event that delays its execution and that therefore causes this undesired effect. Measuring this type of experience has become so important that the metric CLS, cumulative layout shift, is used to measure these unexpected changes in a page. In our wiki, you'll find information on how to reduce CLS. The closer this metric is to 0, the better our application will score. Actually, among the dev tools, I'll only show the web, not devices, and zoom out. We have Google's tool, Lighthouse, which is a performance and audit tool that's used to improve the overall quality of web pages by evaluating aspects, such as performance, accessibility, use of web development best practices, search engine optimization, and PWA. The CLS metric will be used for performance evaluation. We're going to ask it then to analyze the loading of our page for desktop size. Here I accelerated it in the video because it took 10 times longer. We see that it suggests running the same in an incognito window. You can test it later. Now I want to show you that it gives measurements in the 5 dimensions, of which performance is highly relevant. If we go to the disaggregated metrics, we see CLS, which is not 0, and that probably has something to do with this unwanted layout change we've been talking about. It may seem that it's the least important to take care of, given that all these performance-related metrics are shown in red. However, it's normal that now they're shown like this. At the time of deployment to production, we should change one property in the KB preferences, the build mode, changing it to distribution. And this alone will improve this performance metric by at least 30 points. We don't do it in the development stage because it greatly increases times. On the other hand, we must address the CLS metric from the beginning. What would we have to do to reduce CLS? Remove the caption assignment from here. Leave it empty. What's the problem with leaving it empty? This one, that the presence of the control in the layout is invisible to us unless we click on it. It's convenient to consider all these matters from the beginning to avoid this type of issue later. And that's why I wanted to tell you about them in this video before we go on. Finally, since I'm in the middle of the recommendations section, several videos ago, we mentioned that it's very important for us to optimize development times. That's why we're prototyping locally. I'll close, before moving on, the 2 server windows, the front-end server and the back-end server. The entry point of our final application is going to be the home object, and that's why we had configured it as main program, and we can run it with the run option. Actually, it would have been reasonable to configure it as the startup object, which is what I will do, so that we don't need to select it and click on Run, but simply press F5 to run it. Note that now, for F5, instead of offering the Run option of the developer menu that opens the Launchpad, the Run option of the home is shown. Let's run it. It'll specify, generate, and compile the entire dependency tree that starts from the home object, and then start the backend server for the services and the front-end server for the Angular application. This is the one for the Angular application. Every time the server is shut down and restarted again, that initialization takes time, and the application is also assigned a different port. This will be clear soon. And this one here is the backend server, which is where the services are always located. For example, our wait procedure, which is no longer invoked now, but when it was served from here. And here we see what I was telling you. It opened in another tab because the port is different from the previous execution. And that's why I closed the windows before, so that you could see this clearly. If we were prototyping in the cloud, none of this would be obvious to us. But as a trade-off, the times would be longer, since you have to transfer the whole package every time to the cloud server. Well, what's our problem now? That if we want to execute the attractions panel, as we don't have access to it from the home panel, the provisional solution that we had found before was to also declare it as main. That is to say, we're generating a second application. From there, we can also run the object. which will compile its entire dependency tree and will have to open another server on another port. So before pressing run, we have to close the two servers, which will involve the cost of starting up again and installing the package, now attractions, from scratch. All of that equals lost time. Instead, we now have the servers open for the home application. So if we make a change to any object in its tree, for example, this one, let's add a button with an associated attractions event. That I'll leave empty for now. Then I'll call the attractions panel from here. This way, the panel's connected inside the application, even in a provisional way for prototyping to optimize our development times. When we implement the menu, we'll be able to remove this button, so it's convenient for us to be more efficient in terms of development times. Now we run the home. It opened in the same tab as before, on the same port and with the button. So, the recommendation is that we temporarily include the button with the invocation to attractions, and then reassign the default value to the main program property, which is false. We run it. And we press the button. Here we have the attractions panel. Let's bring it back to 100%. Good. Note that we're still in the same port, with the same application. Finally, remember that the startup object is configured at the level of the active environment. You can see it here. In case you want to return to the previous situation, that was no startup object. And when you do it, in build, you'll see that F5 is associated again with the run option of the developer menu.
Bueno, y con este
Well,
término
that's
los que
the end of
querían y
what I
viéramos
wanted us to
juntos
see together in this
y
video.
los espero en el
I look
siguiente.
forward to seeing you in the next one.